Hey everyone, today we're going to do partition labels. So let's get started. A string S of lowercase letters is given. We want to partition this string into as many parts as possible so that each letter appears in at most one part. And return a list of integers representing the size of each of these partitions. Okay, so to me that's a lot of just like mumbo jumbo, what's going on. I'm intimidated already. Okay, so take a deep breath. It's not too complicated once you understand the problem. So let's try to understand the problem more by looking at the example. So our input S is a string and it's just a bunch of these characters. And our output is 978. Okay. The partition is A, B, A, B, C, B, A, C, A. Right? So this is one partition, right? And the next partition begins and ends here, as the example says here. And then lastly, this partition. Okay, so how does this make any sense? This is a partition so that each letter appears in at most one part. Okay, so look at this. So we can see this. We have this character A, and we want to have partitions where every partition has all the characters, there's no partition that has A, basically. So form the smallest partition such that no other partitions have A. Okay, so the smallest partition has to be this, right? It can't be ABA because we know there's an A that comes up later. And so this is the earliest time that that's the last A that we see. Okay, and that works because the first B and the last B also are contained within the first A and last A, as it goes for the C. So this is fine, right? For example, this next one, right? D, let's look at D. D's first character is here and its last character is there, right? But we see that the partition ends in the E. So why is this, right? You would think it could end here, but we can't do that because within that subarray or subsequence, we find a letter E, and that means because E is now in the subsequence between the two D's, we have to look for the furthest E, right? So the furthest E is this one. And F, right? We have to find the furthest F, but there are no other Fs. And we have to look for the furthest G, but there are no other Gs. Okay, so this becomes our next subpartition. Same goes for H, right? H, there's only one of them, right? Oh, there's two of them, sorry. This is the closest bounds for H, and then comes the closest bounds for I. But since the I falls between the bounds for H, we have to extend the bounds for H to be the furthest I. And then we find J. We have to extend the bounds for H and I because J is in that same original bounds. So this becomes our next partition. And so basically we want to do that in a programmatic way. And how do we go about doing that? Let's figure that out. So yeah, for the first thing came to mind here, what we talked about just now is we're going to need the first value and the last value of each of the characters, the first index and last index of each of the characters, in order to kind of see what kinds of partitions can be made. Okay. Once you have the first and last indices of each character, we can basically have a set of ranges. And what we can do with those ranges, basically merge overlapping intervals, which we did a question for already. So we can apply that same logic to this question, merging overlapping intervals, where each interval is the start and last index of that character. And so then we'll end up basically having as many overlapping, once we merge all the overlapping ranges, we'll be left with the number of partitions in this string that we want. Once we have the number of partitions and the first and the last index of those partitions, we can calculate the size of each partition based on basically the last index minus the start index. Does that make sense? If it doesn't, just keep watching, and we're going to code this up. And actually, my approach that we're going to do right now isn't necessarily the best approach. And so after this question is done, we're actually going to go to the discuss tab, and we're going to look over an existing, better solution, and talk about how it's different than mine. So yeah, the first thing we want is to get the ranges of each of the characters. So we can say ranges equals self dot get ranges given S, right? Then once we have the ranges, we want to merge the ranges. So merge ranges equals self.merge ranges of the ranges. Once you have the merged ranges, we say, okay, for each merged range, we have an output array, which is what we want, so partitions. For each merged range in our merged ranges array, we want to get the size of that partition. So partition size equals merged range of 1 minus merged range of 0. And then partitions dot append partition size, and then return partitions. Okay, so this means after we've gotten all the ranges, after we've merged overlapping ones, now we have an array of ranges that represent the partitions. And so we want the size of those partitions, so we can just do this little for loop here. Okay, so how do we get the ranges? So define get ranges, takes self and S. Okay, so we can say for index and character in enumerate S, we want to say, well, we need the ranges, dictionary. So for index, character, and enumerate S, we can say ranges of character equals ranges.getCharacter with a fallback to an empty array plus equals the array that holds this index, right? So what we're doing here is basically collecting all of the indexes at which this character appears in the string. Okay, once we have, now we're going to have something like, a dictionary that's like A shows up in 0, 4, 6, right? What we really care about is getting the first and the last element, okay? So now we have the ranges and we're not necessarily interested in the characters anymore, okay? So what we can say is we want the first and last indices, right, as ranges within this outer array. So we say for interval in ranges.values, right? For each interval in there, we want to take, the interval can have as many, 0 to 1 to many values in it. So what we want is to get the first and last. So we want to say first and last dot append, and we want to append our interval 0 and our interval, the length of the interval, -1. Right, so we're saying take the first index and look for the last index. It could be that the last index is the first index when that character only appears once, and that's fine. So just have a range that's 0, 0 or 1, 1. That's fine. Okay, so once we've done that, we return first and last. Okay. Okay, so now we have the ranges, and now we want to merge them. And these ranges are just the first and last indices of every character. Okay, so merge ranges, and I've done actually this question, the merge ranges question, before on my channel, so check it out. I'll put a link in the bio, a link in the video in the description. So ranges, cool. So if not ranges, we return, empty array. If there are ranges, we want to say, okay, first we have to define our output. So merged ranges equals empty array. The first merged range is going to be the first of our ranges. So take that, and then we say for interval in ranges after the first one, so 1 to the end, we'll say, make some extra space here. Oops. We'll say for every single interval, we're going to say, okay, if this interval's start value is less than or equal to the last value in our merge range's end value, then they're overlapping. And if they're overlapping, we'll say, okay, old start, old end equals merge ranges.pop. So if they're overlapping, we're going to have to merge the existing last range with our current range. So we can pop the existing last one, and we'll say merged ranges.append the new one, which is going to start at the old start, but it's going to be the max value of the old end and our current end, which is interval 1. Cool. If they don't overlap, we're going to just merge ranges dot append our current interval. So then here we can return merge ranges. Okay, so here we have finished this. So we got the ranges, start and end values, start and end indices. From that, we've merged our ranges for all the overlapping ones. So now we have as few ranges as possible, and then once we have that, those are our partitions. And so what we do is for each of the partitions, collect the size of that partition and append it to our output array, partitions array, and return. And so I think that should work. Let's run the code. Invalid syntax. Okay. Oh yeah, obviously. This should just be a plus sign, not a plus equals. So let's see what happens here. Okay, list index out of range. Okay. This should be, yep, okay, so here we have merged ranges of 1. We really want to see the merged ranges of -1, the last merged range, and its end value. Okay, so the last merged range, its end value should be greater than or equal to the start value of the current range. Yeah. Cool. So actually, wrong answer. So we're off by 1 in each of these things. So leads me to believe our solution is somewhat correct, but our just computation is wrong. So where are we collecting these partition sizes? We have the end value and the start value. So what's actually happening is our end value is the index, but we want the size. And so we actually have to add 1 to all of our sizes to get the size of the partition rather than the start and the end index and the last index. So let's run this again. We should see that it's now working. Okay, cool. But is it actually working for any kind of input? Let's do all A's, see what happens. Cool. Let's do all A's, but have a B in there, or empty string, let's call it. Cool. Our expected output, actually S will have a length in range 1 to 500, and so therefore it's not a valid test case. So let's do S, a single string. Okay, cool. So let's submit this and see how it goes. Cool, so not bad. Yeah, let's talk about the better solution that I found on the discuss board. So this is the solution from the discussion board, and so I wanted to discuss how they're doing this one. And so they're using the similar approach in that they're getting the last seen index for each character in the string. Okay, and they're storing that value in a dictionary, right? So they're storing only the last seen index and not the first seen and all the other seen indexes. Okay, once they have the last seen index, they're going to say, okay, keep track of the maximum last seen value for each of the characters. So they're going to iterate through the characters. They're going to say our max last seen is either our max last seen we've seen already, or it's going to be the last seen of the character we're on. So if you imagine a string that's like AAA, BCDA, right? The first iteration of this for loop, max last seen is 0. Then we hit max last seen equals max of 0 and the last seen of car. Last seen of car is going to be 0, 1, 2, 3, 4, 5, 6. So now our max last seen is 6. And so for every other character that we see until we get to 6, we're going to increment our counter because that's going to be the size of our partition. Now actually, if we had a B here, our max last seen would be 6 until we hit B. B's last seen char will be 7. And so our max last seen is now 7. So we keep doing this until our partition, our index is 7. Once it's 7, that's going to be the size of our partition. So we store the size in the partition sizes array. We reset the counter to 0, our size counter to 0, and we continue on with the string. Once we've finished that, we'll eventually The max last seen will be the last index of the string. We'll reach that last index. We'll append that size to the partition sizes, and we'll return partition sizes. Now, I think that both solutions are fine. I think both solutions run in similar time complexity, and this one is obviously a lot less code, but to me personally, the other one is a bit more understandable and readable, right? This one you take advantage of this is a nifty trick to store less amount of data, but it's kind of harder for me to understand. And so I lean towards readability. And so that's why I decided to post my solution as opposed to this random person solution. So let's just run this and it's going to work, hopefully. Yeah. So see, same exact stats. So I'm not really concerned with performance. I'm more concerned with understandability. And in that regard, I think mine is a bit more understandable, but that's just my bias. Yeah, so thanks. This was a fun one. I actually got a little nervous when I started it, but ignore that and you can kind of focus better. And that's what happened. So thank you. Please like, subscribe, comment. How could I do better? And yeah.